Ammonia derivatives are also neutral nucleophiles, and those can react with carbonyls in presence of a mild acid. The acid that we use here is different than the acid that we use with alcohol and water. The acid here is used in the second step of the reaction. So the first step, the nucleophile is going to attack the carbonyl. There will be no protonation of the oxygen in the mechanism. Amines are classified into ammonia, primary amine, and secondary amine. So the reactions for ammonia and primary amines are the same because both they have two or more hydrogens. So you can lose two hydrogens from the nitrogen and an oxygen from the carbonyl. Combine everything together and you're going to get an imine product. Imine is a carbon double bond O product. Let's have an example over here. So the first thing that you do whenever you see these reactions, see what type of ammonia derivative do you have. So if you have a primary amine, as in this case, so this one is a primary amine, all what you need to do is lose water. So you're going to lose two hydrogens from the nitrogen and an oxygen in there from the carbonyl and combine everything together. So you are going to put the nitrogen here in place of the oxygen and you're going to form your imine. As I said, imine is a carbon double bond nitrogen compound. We can do the same thing with ammonia because ammonia also can lose two hydrogens. So here I'm going to take two hydrogens from the ammonia and an oxygen, and this is an imine as well. Another example over here. So as long as you are working with a primary amine, then lose the water in presence of an acid, mild acid, and get the imine. So ammonia is considered to be a base. Yes, it is a neutral nucleophile, but this one is basic as well. The lone pairs are basic. So the lone pairs can attack the carbon of the carbonyl in there instead of the oxygen being protonated in the first step. So in the first step, there is no acid whatsoever. The acid starts in the coming steps after you make your intermediate. So the nucleophile is going to come, attack the carbon, form a negative charge on the oxygen in there. You will have a hydrogen shift. This is called a proton shift in there. Since you have a base and you have an acidic hydrogen in the structure, instead of adding a base to take that acidic hydrogen, we can simply use the base that we have in the molecule to take that acidic hydrogen in there. So you're going to end up having an OH and an NH, and this is going to be our intermediate. Okay, the intermediate is called a carbonyl amine. This is the carbon of the carbonyl over here. It's a carbonyl because it's a carbon that is connected to an OH, and at the same time it is connected to an NH. This intermediate we won't isolate, so the reaction continues now. Now we are going to add the acid. So the acid now here, because the reason why you want to add the acid is you want to get rid of the OH. So you want to do a dehydration in this reaction, because after all, if you look up there, you are losing water. So the reaction is going to proceed by addition of the acid. I do have an OH, so every time you have an OH, an acid in there, you're going to lose water. You're going to form water and lose water. So here we're going to form water and then we're going to lose the water by resonance, and we're going to create our product. If there's any extra hydrogen in the product, then water is going to come, or any base in the solution will come and take the hydrogen, and you're going to get your product, which is the imine. Now, the reaction with secondary amines is a little bit different, because with secondary amines, I don't have two hydrogens to lose over here. Let's go ahead and consider the mechanism of the reaction so that you would understand better what's happening in there. So the nucleophile is going to come and attack the carbon of the carbonyl. So we agreed with nitrogen derivatives. The acid you are going to use it after you create your intermediate. So nucleophile attacks forms a negative charge on the oxygen, and then I can do a hydrogen shift. So do a hydrogen shift in there and make your intermediate. The intermediate here over here is going to be again a carbonyl amine. Now, after you form your intermediate, you're going to go ahead and add the acid in there in order to make water. Once you make the water, you cannot do as you did with the mechanism of the primary amine. This nitrogen has no hydrogen. So you cannot say that I'm going to use the lone pairs in here to make a double bond and kick out water. Because if you do this, the nitrogen will be a plus charge. It has no hydrogen around, so you won't be able to get rid of the plus charge of that nitrogen anywhere. So this is why the elimination is not going to happen between the nitrogen and the carbon. Before, with the primary amine, the elimination happened between the carbon and the nitrogen in there. So you ended up forming a double bond from the lone pair and the water left. When you formed the double bond in here, the nitrogen assumed a plus charge, but because it had a hydrogen, I could use water in order to take the hydrogen out and create a lone pair back to the neutral. I could do this. But here, no, because if I form a double bond in here and kick out the water, the nitrogen here has no hydrogens to lose. So I'm going to be stuck with the positive charge on the nitrogen, so my product will not be neutral. This means that the elimination cannot happen between this carbon and this nitrogen. Let's highlight that. So elimination cannot happen here, okay, between the carbon and the nitrogen due to the fact that the nitrogen here has no hydrogens whatsoever. So this is why elimination needs to happen on the adjacent bond of the nitrogen in there. And we want to form the most stable alkane, meaning that the most substituted alkane. So the base in the solution, any base in the solution like water, HSO4 minus, or another mole of the secondary amine, will take the hydrogen. You're doing elimination here. It's going to come and take the beta hydrogen. It's going to form a double bond and kick out the water. So your product in this case, instead of forming a double bond between the carbon and the nitrogen, you'll form a double bond between the carbon-carbon bond. And this is called an amine. And let's have an example for this reaction in here. So let's say if I start with an unsymmetrical ketone, and I am reacting this with a secondary amine. It's very important to figure out what type of amine that you are working with for these reactions so that you would know what type of product you are going to get. If I want to get the product directly without doing the mechanism of the reaction, so all what you need to do is lose the hydrogen over here, lose the oxygen, and then combine the nitrogen together with whatever R is connected to, add it to this carbon, and then move the double bond. Because this is unsymmetrical, you can move the double bond either to this side or to this side, because you can have elimination either on this beta hydrogen or on this beta hydrogen. So you're going to end up here in this case having two products. Let's go ahead and draw these two products in there. Here you go. It's going to be a single bond. And now the double bond is going to be either on this side over here, plus over here, the double bond is going to be on the other side, like that. So you're going to get two enamine products. Show them both. Now, which one is major? Of course, the one which is the most substituted alkene is going to be the major product, and this one is going to be the minor product. Let's go ahead and consider the mechanism of the reaction. Mechanism. We are starting with the unsymmetrical ketone. We are reacting it with a secondary amine. Okay, in presence of an acidic medium. So we agreed that the first step, the nucleophile is going to come attack the carbon, form a negative charge on the oxygen. So you will end up forming the addition of the nitrogen to the carbon in there together with its R's. There you go. So I would have a hydrogen over here with a plus charge and a CH3. Now my next step here is going to be a hydrogen shift where the oxygen, which is the base, is going to come and take the acidic hydrogen and form a lone pair on the nitrogen. So the nitrogen here will have no hydrogens left. And my intermediate is going to be reached. So I'm going to form my intermediate in here. It's going to be the nitrogen and the CH3 in there. And this is going to be my lone pair, and that is going to be my carbonyl amine intermediate. Now, once you form your carbonyl amine intermediate, it is now that we're going to go ahead and react that with the acid. So the acid is to protonate the oxygen and make it NOH so that elimination can happen. So here you go. This is going to attack the H plus, and the OH will get protonated with the lone pair. So water needs to leave, and it cannot leave on its own like this. So elimination needs to happen. You don't have a hydrogen over here to eliminate the hydrogen, but what you have is a hydrogen on this carbon, and you have a hydrogen on this carbon. So let's consider the first hydrogen over here. So this is going to be my H in there. So the base in the solution has two routes to come and take the hydrogen, because we do have two hydrogens here. And this is another hydrogen. This is hydrogen A, and this is hydrogen B in there. Considering this is the alpha carbon, then this is going to be my beta, and that's going to be my beta. So my base, and the base can be any conjugate base in the solution. So we're going to use the HSO4 minus in there, or you can use another mole of the secondary amine, because this is also a base. So any base in the solution can do the job. So the base is going to come now. It's going to take the beta hydrogen, form a double bond like a regular elimination. And you are going to get your first product. There you go. So you have your double bond in there. And you have the nitrogen. And this is the amine product, first one. And then the second one, the base can come, take this hydrogen, form a double bond, and water can leave. And you're going to get your double bond on the other side now. This is the less substituted alkene that you are forming, which is the least stable one. So that is going to be the minor product, and this is going to be the major product. Now, in most of the cases, I will ask you to draw both products. So please go ahead and draw both products in the reaction. There are other derivatives of primary amine that we can also consider. So all of those that you are seeing, these are primary amine derivatives. You are not responsible for the mechanism of this reaction, although it goes exactly the same as the primary amine mechanism, but I'm not going to ask you about it. So since each one of those are derivative of primary amine, they do have two hydrogens in there. So all what you need to do is take the two hydrogens and the oxygen, combine everything together, and your product is always going to be an amine. A very important test that we use in order to identify aldehydes is the Tollens test. The Tollens test is a test that uses a Tollens reagent. And the Tollens reagent is a reagent that is made up of silver ammonium nitrate. So you have an NO3 in there. And that silver ammonium nitrate, normally you combine it with a base, and your solvent is water. So all of this is called a Tollens reagent. And the Tollens reagent is an oxidizing reagent. And that reagent oxidizes the hydrogen of the aldehyde, and you're going to end up, because it's a basic medium, you're going to end up getting the base of the acid. Plus, you are forming a silver precipitate in your test tube. So the walls of your test tube will look like a mirror because it's a silver deposit in there. This is why we call it a silver mirror test. So with this type of reaction, this is positive for just aldehydes, and aldehydes get oxidized into the base of the acid. So you're going to end up, instead of having an OH in there, you're going to have an O minus. Ketones, because they don't have a hydrogen in there with Tollens reagent, there will be no product.